Nuclear fusion has potential beyond our imagination. It has the power to fuel the stars, and if it could be replicated on Earth, it could provide practically infinite energy with zero carbon emissions. Unlike current efficient nuclear technologies, nuclear fusion does not produce long-term radioactive waste. For decades, it has seemed within reach. But the immense reward has continued to channel billions of dollars into the field. In this sense, Germany's leading plasma physics research center has achieved a new record with its new nuclear fusion reactor, demonstrating that we are moving closer to the wonderful goal of fusion power, a nearly infinite source of clean, renewable energy. But what is this new nuclear fusion reactor and what does it do? How does it compare to the pioneering ADA reactor? The effort to develop a nuclear fusion reactor capable of producing abundant and sustainable energy, or mimicking the sun, has made another stride forward. For physicists, fusion is a sort of holy grail, with the potential to be a safe and clean source of nuclear energy if successfully exploited. Unlike nuclear fission reactors, fusion combines atoms rather than splitting them. Thus, it does not produce dangerous radioactive waste. Scientists at the Max Planck Institute for Plasma Physics have started an experimental reactor and produced hydrogen plasma in a device known as the Wendelstein 7X Stellarator. This is designed to contain plasma formed by fusing hydrogen atoms together and bombarding them with microwaves until they reach temperatures of 100 million degrees, in which the nuclei of the atoms fuse to form helium. The process generates energy and reflects what happens in the sun's core. The donut-shaped core of the Stellarator essentially creates a mini-star. This device debuted in 2015 at the Max Planck Institute for Plasma Physics, proving that it could maintain a flow of helium ions heated to 1,000,000 degrees for 1/10 of a second. While most of us are familiar with traditional nuclear energy, generated by the disintegration of large atoms, fusion energy is created when atoms are fused together. It is the most promising energy source of the future because it doesn't produce the same radiation issues as atomic power. The ADA nuclear reactor is another technology expected to inaugurate a new era of nuclear fusion energy. ADA is the first and largest machine of its kind in the world, currently under construction at Cadarache, a French scientific research center specializing in nuclear energy research. The machine will produce 500 megawatts of power by fusing two different types of hydrogen, known as deuterium and tritium, 10 times the amount of energy it would take to run ADA. The Wendelstein 7X Stellarator has demonstrated that power plants using Stellarator-type fusion reactors are feasible. Indeed, significant theoretical and computational effort has been made to design the magnetic field that keeps the heated plasma contained and away from the sides of the vessel. One of the main objectives was to limit the plasma's energy losses due to the ripple of the magnetic field. Even though Wendelstein 7X won't produce energy on its own, it will eventually be used to create a Stellarator reactor that can operate indefinitely, bringing us closer and closer to a world of almost limitless energy. Provided by the same process that powers the sun. We are looking forward to your comments on the nuclear reactor in the section below.